2.5.1 Graphing piecewise functions. Essential question. What role do the domain restrictions of each piece play in the overall appearance of the graph of a piecewise function? Skill. I could sketch the graph of a piecewise function. Graph the piecewise function given below. We have f of x equals x plus 1 for negative 2 is less than x is less or equal to 2, and then x minus 4 squared for x is less than or equal to 7. That doesn't make sense. Let's change that to a 2. Alright, first let's go ahead and draw our bounds for restricted domains. So it looks like we have negative 2. And we have positive 2. So we want to find some values. We're going to say that this is the left piece and this one is the right piece. Sometimes they're not in the correct order, so you want to label those. Let's also write our other boundary at 7. Alright, let's make a T-chart. Let's plug in the points. Negative 2, because that's one of our boundaries. Let's plug in something between that. Let's choose 0. And then 2. And then let's choose some other ones. Let's do like 2 more in this one. This gap looks bigger. Do 4. And let's do 6. And then our other boundary 7. Alright, so for negative 2, 0, and 2, we're going to use the left function. So negative 2 plus 1 is going to equal negative 1. 0 plus 1 is going to equal 1. And then 2 plus 1 is 3. And we're not going to use the left one for these pieces. Now for the right side, we'll still use 2, and then we're going to use the 4, 6, and 7. So we won't use these first ones. 2 minus 4 squared is equal to negative 2 squared, which is equal to 4. Alright, 4 minus 4 squared is equal to 0 squared, that is equal to 0. 6 minus 4 squared is 2 squared, that equals 4 again. And then our boundary, 7 minus 4 squared, is 3 squared, and that equals 9. From here, let's plot our points. Negative 2 and then negative 1. It's not included because it doesn't have a line on the inequality, so we're going to put an open hole. 0, 1. So we have a closed point, that's part of the line. And then 2 is included, is 3. This is a linear, so we're just going to connect these as a straight line. Okay, now we have 2, 4. That doesn't have a line, so we're going to put a hole. 4, 0. That's a point. It's part of the quadratic. 6, 4. Put that right there. And then 7, 9. And that's the end of the piecewise. We're going to connect these as a parabola shape. And notice it stops here on both sides because it doesn't extend infinitely. It's bounded by these pieces, these restricted domains they're given. Go ahead and try the next ones on your own.